Yes, Steven, can you hear me? Am I audible to you, Steven?
Yes, sir.
Okay, so we will start. Let other will join. So this is session 3. We will discuss kinematics of fluid flow. Till now, we had discussed only about fluid statics, and in this we had discussed, and in this we had discussed about um, fluid at rest, and there we had discussed about Pascal's law. Then we had discussed force on plates submerged in body. Then we discussed center of pressure and also stability of submerged bodies. And before that, we had discussed about basic concept of fluid mechanics. Then now we will discuss about kinematics of flow. Kinematics of fluid flow. So what is the meaning of kinematics of fluid flow? It means that the fluid is in motion, but the motion is studied without considering forces, without considering forces. Now, after that, we have a dynamics of fluid flow, and in this we analyze motion of fluid with forces. So now, what is in kinematics of fluid flow? What we will I will go with the basics. Then we will try to solve some questions that will help you to solve the assignment. So now, uh, from your classical, from your classical theorem or law. So suppose I am talking about Newton's law, thermodynamic law. So every laws has been applied to on a system. So what does system means? So suppose this is your body, this is of mass m and applied a force F. So the acceleration is F by m. Okay. So this is what is called system. Like we have in a system, the mass is held constant. Mass is constant and no mass can go in and out of the system. It is not permitted. Only energy transfer is permitted. Now, our fluid is, so suppose if fluid is flowing in a channel, so if I am saying that Newton's law is applied to on a system, but here the mass is changing. Some mass is coming in and going out, coming in and going out. Therefore, the mass is not fixed. It is changing. Hence, this type of approach needs a different way of understanding the system, and hence this is called control volume approach. So suppose, for example, you have a nozzle. Okay, nozzle is used for the accelerating the fluid. So some fluid is coming and some fluid is going. Now we will focus this nozzle as a control volume. And what does it mean is, so in control volume, the mass can go in and out, but the volume in which we are constrained is held constant. Hence, mass can go in or go out. Therefore, in fluid mechanics, there are two descriptions for fluid flow. One is Lagrangian description, and second is Eulerian description. So, what does it mean? So, suppose I am saying in Lagrangian description, you have a tube that out a mass m is flowing inside this tube. So what will happen is we will take this particle and we will analyze that on in which direction this is going and whatever be the velocity of this particle. So it is basically focusing on focusing on particle to analyze the flow behavior. Okay. So suppose this particle is going in this way and then going in this way and this is way. So this is called the Lagrangian distribution. And there are number of particles. So as you can see that the difficulty arises for these number of particles is this is in millions or 10 millions or in billions of number of particles are there. So you cannot apply on each of the liquid molecules the Lagrangian distribution. So what we will do is we will take that suppose there are cluster of particles whose properties, velocities, pressure, and everything are safe. These cluster of particles can be taken as a particle and analyzed. But again, the problem is how we will say that these number of particles are of same behavior and everything. Then in fluid that this term is very helpful and this is very like if you see in later stages that this description is very helpful. Eulerian description. So Eulerian description focuses on particular area or volume and fluid or fluid will flow from that area. So suppose I am saying that this is the tube and here fluid is flowing. So we will focus in this area. Okay. And the fluid will come and go like this. So here the fluid is coming and going. So it is obviously a control volume approach and this is obviously a control mass approach. Now, this This analysis is easy as we can fix certain volume and we can analyze whatever with the fluid is coming and going. So this is called the Eulerian description. So in all the fluid mechanics, all of the works, all the studies has been made in Eulerian description only. Now, as you can see that the differences between the Eulerian and your Lagrangian approach. So, so one example I want to give you. So suppose what is acceleration? So acceleration is defined as change of velocity with respect to time for a particle. Okay, this is what is called acceleration. Now, if I'm saying that my fluid is flowing in a duct and my velocity is not changing with time, so I have fluid that is flowing with v velocity and my v is not changing with time. So that means is acceleration zero? So that question can be asked. So is it true or false? So what can you say about this? Hello?
Yes, sir, this is true.
So that means acceleration is zero, right?
Yes, sir.
But as this is in a confined duct, so your velocity, like from the general intuition that mass is constant and area is decreasing. Area here is A, suppose here A is half of A, this is A1. So what is the velocity at this point? At this point, large or small?
It will be large,
So if,
sir, because yeah, it is decreasing from inlet to outlet.
yeah, so it will be large. That means your velocity has changed. Although velocity has changed, although my velocity is not function of time, but it is a function of space. That means I had changed from one coordinate point to another coordinate point and my velocity has changed. Therefore, in fluid mechanics, we defined uh, acceleration as not only a function of time, but also a function of space. So this is a vector in space that can be x, y, z. Okay. So this is what acceleration can be defined in a fluid mechanics. So in fluid mechanics, I am saying that this is acceleration, that is dv by dt into like this is for the particle in Lagrangian approach, but this is also equal to del v by del t. So why I'm writing it as a partial derivative? Because my acceleration is a function of time and space. Therefore, we if we derivate something, we will write in terms of partial derivative plus del v by del s or del v by del x. This is x variable into del x by del t. This is chain rule plus del v by del y. So how velocity is changing with y into del y by del t plus del v by z del z into del z by del t. So this is dv by dt plus this term if you notify it is u. This is v velocity and this is w velocity. So u del v by del x plus v del v by del y plus w del v by del z. So this is actually a vector quantity because it can be in u, in v, in z. Now, if I am writing v as ui cap plus vj cap plus wk cap, therefore ax is equal to del u by del t plus u del u by del x plus v del u by del y plus w del u by del z. And similarly for y, for z. This is for the Cartesian coordinate system. Del v by del t plus u del v by del x plus del v by del y plus w del v by del z. And this is del w by del t plus u del w by del x plus v del w by del y plus w del w by del z. So this is for Cartesian coordinate system. Therefore, acceleration in fluid can be only made through these equations. Okay, what does it mean that dv by dt for a particle is equal to this term, this explanation, like because your acceleration here is not depending on time as well as space. Now, one question again comes: what does this term means? What does this term means? So this term is called convective acceleration. So if you see your assignment, you will get this. This is called convective acceleration. This is called temporal acceleration. And this ax is du by dt, and this is called material derivative because we are taking a particle which is a material and we are derivating its velocity with respect to time. Hence, here the new terms it introduced, that is temporal acceleration, convective acceleration, and this is same for this all. Okay. Now, so if you see ax, ay, az has three, like each acceleration has a four components, so total around 12 components are there. Now, in short, how we can write this as, so a is equal to d vector by dt plus v dot gradient into v. How we write this? So, like I will give you. So here this v can be like this first. This a can be ax, ay, az. This v correspondingly will be u, v, and w. But what is this form? So if I write it as ui cap plus vj cap plus wk cap into dot product of del x of I cap plus del y of j cap plus del z of k cap. If I make the dot product, what it will be? U del by del x plus v del by del y plus w del by del z. Okay, so this term is this, and this term is again u v w. So if you split as ay az, it will be u, like it will be in the form of u, in form of v, in form of w. So is it clear to you? Hello.
Yes, sir.
Now we will try to, like, this is acceleration. So now we will try to define fluid flow. So first we will yeah. So first we will do something. Suppose the question is there. Lagrangian it is given. Okay. First we will do something later. Then we will do. So, study unsteady uniform and non-uniform flows. So because I had discussed acceleration, we will discuss this. So suppose I'm taking only u component. So ax is equal to del u by del t plus u del u by del x plus v del u by del y plus w del u by del z. Now, this term is called the temporal term as I explained earlier. This term is called the convective term. So we have four cases. Just So I will make these four cases: steady, unsteady, uniform, non-uniform, and uh, this is temporal, and this is convective. So what it means is, so temp, if you're like in a steady state, what happens is your acceleration is not a function of time. That means your temporal term is zero. But we are not saying anything about the convective term. So it can be zero or cannot be zero. In unsteady state, what happens is this is not zero and this can be zero or cannot be zero. Now in uniform flow, your convective term is zero. That means this term is zero, or it means not dependent on space, not dependent on space. And this term means not dependent on time, not dependent on time. So if your this term is zero, that means it's a steady flow. If your this term is zero, it means it's a uniform flow. Okay. So that is the case. So if I'm saying anything is uniform and steady, that means its time derivative is zero and its space derivative is also zero. Therefore, its total acceleration is equal to zero. If I'm saying something is non-uniform steady, then its time derivative is zero, but its space derivative exists. So therefore, A is equal to in vector form. If I write, it is V dot gradient into V. So this is what the non-uniform steady means. So if anything is uniform and non-steady, that means acceleration is partial derivative with respect to time. So this is the meaning of like what is the meaning of uniform and steady, non-uniform and steady, uni like different classifications. So this is a different types of flows. Now we will study. So just for your note, I will not derive that thing. For cylindrical coordinate system, for cylindrical coordinate system, in that system you have AR, A theta, and AZ. So AR is equal to complete derivative of time, material derivative of VR with respect to time minus V theta square by R. And if you split this derivative, it will be del VR by del T plus VR del VR by del R plus V theta by R del VR by del theta plus Vz del Vz by del VR by del Z minus V theta square by R. So this term is coming at the last. This is the split of this part. For theta component, we have dv theta by dt plus Vr v theta by R, and this is equal to del v theta by del t plus Vr del v theta by del R plus v theta by R del v theta by del theta plus Vz del v theta by del Z plus Vr v theta by R. And similarly, you can expand Z. Z is the same form dvz by dt, and it is equal to del Vz by del t plus Vr del V del Vz by del t plus V theta by R del Vz by del theta plus Vz del Vz by del Z. So this is in the Cartesian coordinate system, except two terms are extra, this term and this term. This term is coming from the centrifugal force. So if your fluid is rotating, then along with the change in the direction, a whole momentum will give a rise to a centrifugal force. And this is what the Coriolis force means. So I have one question. So suppose um, u is equal to 2x square plus 3y, v is equal to minus 2xy plus 3y square plus 3zy, and w is equal to, okay, take it in a two coordinates, is 2, and the point is 1, 1. You need to find acceleration. So if I'm saying acceleration, so a is equal to, as explained here, del v by del t plus v dot gradient of v. Now for ax, so this a comprises of ax I cap plus ay j cap. Now ax is equal to del u by del t plus u del u by del x plus v del u by del y. Now what is del u by del x means? Del u by del x, if you write, it is 4x, and del u by del y means it is 3. Okay. Now if I write ax is equal to, and here no time term is there, so therefore del u by del t is equal to 0. Now if I will write, it is 2x square plus 3y, that is u, into del u by del x is 4x, plus v is this whole term minus 2xy plus 3y square plus 3zy, into del u by del y, it is 3. Now this ax need to be find at coordinate 1, 1. Now if I put 1 and 1 in x and y, so sorry, I think I should remove this z part because z is not here. Okay, so this part is not here. Now, so at 1, 1, what will happen? This is 3 to 5 into 4 plus this is 1 into 3 minus 2, this is 1 into 3. So this is 20 plus 3, that is 23, or whatever be the units. So it is 23. Now if I write y, similarly you can do del v by del t plus u del v by del x plus v del v by del y. So del v by del x is equal to minus 2y, and del v by del y is equal to minus 2x plus 6y. So I hope you can know the derivative, how to derive or derivate the things. So if I am derivating with respect to y, I am taking x as a constant. If I am derivating with respect to x, I am taking y as a constant. Therefore, ay is equal to, at 1, 1, you can similarly find, because there is no time term, so time term is not there, del v by del t is equal to 0. Therefore, it is u, that is 2x square plus 3y, into del v by del x is minus 2y, plus whatever be the v term, minus 2xy plus 3y square, into minus 2x plus 6y. So if you put 1, 1, it is 5 into minus 2, that is minus 10, plus this is 1 into, if I minus 6 minus 2, 4, so it is 4, that is equal to minus 6. So therefore, your total acceleration is equal to 23 I cap minus 6 j cap. Is it okay to you? Hello?
Yes, sir.
So, are you getting how to calculate the acceleration?
Yes, sir. Derivate, we will derivate it and get it.
Oh, so what the thing is, ax and ay two components should be there, and this derivation, or not derivation, this derivative is with respect to time and space. Now we will go to the other things. So we will go with some definitions of path lines, streak lines, and streamlines. So this is little little tricky. So I will help you to understand. Then we will solve some questions. So what is path line? So path line is a Path line is focusing on one particle and what path it is following. Now, what it means is, so suppose you have a numerous, so suppose this is your nozzle there and you have a tank. So lots of fluid particles is coming. So I'm taking one particle and it is traveling like this. So if I join this, this is the same particle at different time interval. So it started from x0, y0 at t is equal to t0, and it has traveled from here, 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 and it will go like this. So this is the same particle, and we are traveling and joining the so it's the locus of, that means locus of path followed by a particle. Okay. So from your understanding, you can see that we are following a particle. That means it is a Lagrangian approach to study a fluid flow. So this is a Lagrangian approach to study a fluid flow. Now, in path line, this is like this. And what is the meaning of a streak line? So streak line is meaning that suppose we have a tank and here the fluid is flowing. You have a dropper, a dye. A dye is used to track the particle, and you are injecting dye, injecting that at a certain interval. So suppose one particle is there, you inject that, and after some time another particle is replacing. So this particle has come here, and another particle has came here. So you inject the dye. So it is like at the same point you are injecting. So the point is constant. You are injecting the dye at a different particles, and the locus of all these particles that has traveled from the same point, it is called the streak line. So locus of particle that has traveled from same point, that is called streak line. Okay. So suppose this is your chimney, and from here your cloud or fumes is fumes is going. So this, because at this point at different instant the fumes is coming out. So this is called the streak line. So you can understand the difference between streak line and a path line. Path line is focusing on a one particle, and streak line is we are pointing at a one point. And from this point, whatever be the number of particles has been released, we are tracing that back and we join with a line, and that is called a streak line. Now, what is the meaning of a streamline? Streamline meaning that so streamline it, so it's the imaginary line, so it is not in real. It's the imaginary line in which in which tangent to any element, tangent to any section gives the velocity vector. Or what it means is it's the imaginary line on which tangent at any point gives the velocity vector. Or we can see that we also can analyze from the from the this what's the linear algebra, right? V cross ds is equal to 0. So if you say that it's a cross product of V cross ds is equal to 0, that means there is no any flow perpendicular to that. At this direction it is 0. This is the meaning of this. All the components has been in this direction. That is the equation of a streamline. So if I'm saying my V is ui cap plus Vj cap plus Wk cap, and ds is equal to dxi cap plus dyj cap plus dzk cap. Therefore, if I am making the cross product, so I hope you know the cross product, how to make it. Ijk UVW, it is dx, it is dy, it is dz, that is equal to 0. That means I am taking the ith component, that is v dz minus w dy plus j cap. If I leave this term, it will be u dz minus w dx. Sorry, this is minus, this is plus. If I take this term, it is u dy plus v dx is equal to 0. So for any vectors to be equal to 0, that means each element is equal to 0. Therefore, this is also equal to 0, this is also equal to 0, and this is also equal to 0. And if you make everything 0, it is dx by u is equal to dy by v is equal to dw by z. So this is also equation of streamline. So there may be a question at which of the following is the representation of equation of streamline. This is your answer 1. This is your answer 2. Okay. So this is the like different definition of path line, streak line, and streamline. I hope you are getting this. So we will try to solve one question so that we can understand. So first, from the path line example. So I have given u is equal to x by t plus t0, where this is some initial time. V is equal to v0, and everything has been coming from x0 y0. Now the question is, what is the equation of path line? Therefore, as this is coming from the Lagrangian description, so in Lagrangian definition, you know that acceleration is equal to du by dt, and your x coordinate is equal to, oh sorry, your u is equal to dx by dt from the material system. So suppose this is a particle, it is going, so the acceleration is equal to du by dt, and your velocity is equal to dx by dt. So if we use that, u is equal to dx by dt, that is equal to x by t plus t0, and if you solve, it is dx by x is equal to dt by t plus t0. So at x0, the time is equal to t0, and it is an x, and it is at any time t. If you integrate this, it will be ln x by x0 is equal to ln. So if you write it as at t plus t0 divided by 2t0, or x by x0 is equal to t plus t0 divided by 2t0. Now, v is equal to v naught, and that is equal to dy by dt. So if I integrate this, it would be y minus y0, because it is going from y0 to, so let me write in this way, dy by dt is equal to v0, or dy integration from y0 to y is equal to v0 dt from t0 to t. So this is your initial time at which the particle is at location x y0. So it is y minus y0, it is equal to v into t minus t0. Okay. Now you can eliminate. So you have two equations, equation 1, equation 2, and you can eliminate t0 from both the equations, and you will get the expression as x by x0 is equal to y minus y0 by 2t0 y0. Okay, or it is minus equal to 1. So this is an equation that is in the form of x and y, and you can eliminate t from both the equations to get the equation of a path line. Now, to solve the same question, so suppose I'm saying that the question is same. It is x by t plus t0 and v is equal to v0, and we need to find the equation of a streak line. So what is the difference between both? So here in the past line we follow the Lagrangian approach. But what is the difference in obtaining the equation of a streamline? So in streamline, the point is held constant, and another thing is that is constant is so suppose I told you that from at this point we are injecting a dye and it has a different particles has been traveled. So in path line, initial time is given and initial distance is given. In a streak line, initial point is given and it is told that at t less than equal to some t naught, the dye injection has been made. So suppose dye has been injected till t naught times. T naught times means we can say that suppose 5 seconds. So your final time of dye injection is given, and we have to find what is the equation. So in path line, initial time is given. In your streak line, your final time is given. That for this whole time, your dye injection has happened. Now obtain what is the equation of a streak line. So the expression would be same. Dx by dt is equal to x by t plus t0, or dx by x is equal to dt by t plus t0. But the thing that will change is it is started from x0 to some x, but the total time that is given is, so suppose it is given that till t is equal to 2t0, dye injection has been made. This is your final time. So in the top the portion it is 2t0 and in the initial it is t. So it is like your final time is known, your initial displacement is known. Now you solve the problem. So in streak line that is a difference. And the expression would be x by x0 is equal to 3t0 by t plus t0. So this is some time. Now similarly for y, dy by dt is equal to v0, and if you integrate, it is dy, so integration from y0 to y is equal to v0 dt, and initial time is t and final time is fixed. So it is y minus y0, it is equal to v0 2t0 minus t. Now here is t, here is also t. We will eliminate this t to get the equation, and because you can substitute like in this way. I will give a demo. X by 3t0 x0 is equal to 1 by t plus t0, or t0 is equal to, if I reciprocal it, 3t0 x0 by x minus, sorry, this one would be t. So if I put this equation in this equation, so you can get x by x0 1 minus y by y0 divided by 3t0 v0 is equal to 1. So this is the equation of a streak line. Now we will try to look at like till here we had discussed about how we describe the fluid flow. Like we really don't focuses on the what is the acceleration, like what is the forces that is causing the motion, or what is the what is the types of forces. We only said how we describe the motion. So in fluid, it is different from the mechanics point of view. Now we will do some. We will do like see what is deformation, rotation in fluid flow. So first we will get some basics from the solid. So in solid, what happens? Suppose this is a solid body. You can elongate with while applying some forces, so it will deform. Okay, it will deform from the this original shape to this shape. You can rotate this solid body. So if suppose this is solid body, you can rotate this solid body like this. Similarly, in fluid also. So suppose this is your fluid element. So in solid body, you know that it is very rigid. You cannot change the shape very arbitrary. But in solid body, you can change the shape because it can move in this direction, in this direction, in this direction, and in this direction. So we have like in the fluid, although in solid there is a deformation, but it's very less. But in fluid, deformation can be made very large. In fluid also we can rotate, like rotation can be done in the whole fluid element. So suppose this is fluid element, this thing can be rotated in this direction. Now, what is the equation like in solid? We know what is the elongation, what is the rotation meaning. So if something is rotating, we call it omega. If something is deforming, we call it some delta and uh, delta by delta x, and we represent it using the modulus of elasticity. But how we do in the fluid element, how like if some deformation is there, how we make sense of it or rotation is there. So first we will do with linear deformation because it can be linear, it can be angular because fluid has a tendency to gain any shape in which it is filled. So suppose this is your fluid element, it is delta x, it is delta y. Now what will happen? So suppose it has elongated. So although it is linear deformation, therefore there is no any angular movement of the. So this is your earlier fluid particle, and this has elongated. I have shown in the green one. Now, so what we can say is, um, let me, okay, or it should be, okay, just a second. Okay, this is your like suppose this is your 11. I drawn in a very big way. So this is your earlier fluid element, uh, and this has changed from this deformation has happened, and it has changed from ABCD to some ABCD. Okay. Now we need to find like how much deformation has happened. So suppose this has a velocity of u. So what is so this phase has some velocity of u. So what is this velocity? This velocity is u plus so sorry, this is delta x and this is delta y. This is in x direction, this is in y direction. So it is u plus delta x of u into delta x. So if I'm saying I am moving ahead with delta x, so my u has changed from u plus del u by del x into delta x. Similarly, this velocity is v, therefore this velocity is v plus del v by del x into delta x. Now, what it means? So in delta t time, in delta t time, this v has moved from here to here. So this phase has moved from here to here. That is u delta t. And this phase has moved from here to here. That is u plus del u by del x delta x into delta t. So what is the total length of the phase now? So if I say, I should use black pen. So this is your initial length, that is delta x. So delta x is your initial length. And what is your final length? So if I am saying my final length is, this is your initial, and my final length is, it is, this has moved from u delta t. So if I subtract delta x minus u delta t, this is this much plus u plus del u by del x delta x into delta t. So this is also u delta t. So this term will go out and it is delta x plus del u by del x delta x into delta t. Now, this is your initial length that was delta x only. Now this has changed from this length plus this length. So this length is u delta t minus delta x. So what is the deformation in x direction? Linear deformation in x direction is equal to delta x plus del u by del x delta x into delta t minus delta x. So this is the deformation that happened. Okay. And if we want to find out, this is the deformation that happened, and with respect to what is the dimension of the original dimension in x direction, that was delta x. So initially it was delta x. Therefore, if I say this term and this term will go out, and this term and this term will go out. So if I am saying the deformation in x direction, that you can explain from your solid mechanics also, that is del u by del, what is del u by del x into delta t. And in fluid mechanics, you know that we are interested in rate of deformation rather than only deformation. So I am taking this part here only, and it is the rate of deformation. It is del u by del x. So it is in x direction. Similarly, for y direction, if you go, the rate of deformation, it is del v by del y, and in z direction, it is del w by del z. Therefore, if I put that together, a silent, like, rate of deformation in x direction, rate of deformation in y direction, and rate of deformation in z direction, that is equal to del u by del x plus del v by del y and del w by del z. Now, what is the meaning of this? So what is the meaning of this? First, we will see. So suppose this is volume, that is equal to delta x into delta y into delta z. I am taking both sides log. It is log delta x plus log delta y plus log delta z. Now I am derivating with respect to time. 1 by delta x dx by dt plus 1 by delta y dy by dt plus 1 by delta z dz by dt. And if you see this right hand side term, this right hand side term is equal to this term. Therefore, the it is 1 by v dv by dt is equal to del u by del x plus del v by del y plus del w by z del z. And if this term is equal to 0, that means dv by dt is equal to 0. And what it implies is your flow is incompressible. That means your change in volume is equal to 0. That means v is equal to constant. Therefore, for incompressible flow, del u by del x plus del v by del y plus del w by del z is equal to 0. And if we want to write this in vector form, it is del dot v is equal to 0. So this del is, I will expand this. It is del x of I cap plus del y of j cap plus del z of k cap into ui cap plus vj cap plus wk cap, and this is a dot product. So if you make the dot product, it is del u by del x plus del v by del y plus del w by del z. That is equal to 0. And this is the explanation for the incompressible flow. So this is in form of vector notation. This is in form of like algebraic notation or scalar notation. So this is for the incompressible flow. Now this derivation is for the linear deformation. Now what happens is if there is an angular deformation. So if suppose angular deformation. So if I am saying this is your fluid element initially perpendicular, and this is your delta x, this is your delta y. I should make it very big because it's a lots of things is coming here. Okay, so this is delta y, delta x. Now we are considering only angular deformation, no linear deformation. So this term has after delta t time, this fluid element has deformed like this, some deformation like this. Okay. So if I'm saying this was my initial deformation, it has changed from this form to this form, or I can make it little big for your convenience. So this term has go up like this. So it has not gone translation. Why? Because initial point is same, but it has changed its angle like this. So if I'm saying this is alpha, this is beta. So it has go from alpha in this direction and beta in this direction and has gained this amount of shape. That is, if I'm saying this is A, B, C, D. Now we need to find out what is the rate of angular deformation, and here one terms also came the rotation concept. So first thing, suppose this is B prime. So this B has gone up here. So if we want to like split this B part, so this B part has changed from like suppose this is your if I'm saying this is also equal to alpha. Okay, this is alpha, this is also equal to alpha. So my thing is how this thing has changed. So first of all, this is delta x. So suppose this is u, and this space has a velocity of u plus del u by del x delta x. This space has this velocity in this direction, and it has elongated from B to C. So this length is equal to u plus del u by del x delta x into delta t. My initial point is same, but with time this has changed. Okay. Now this was my like y direction. Okay, and it has gone up from like if you see it has gone some angular deformation. So what is the displacement of this value? So or I think it's not only this, it is this value. So this phase has a velocity in this direction and it is called y. So this has this component v and it has because it has moved in x direction, this component is equal to uh, v plus del v by del x into delta x because it has moved from this direction to this direction. So your v has changed from v to v plus del v by del x into delta x. And because of this, this point has moved from here to here. So because of x component, it has moved from here to here. And because of y component, it has moved till here. So into delta t. Now, what is tan alpha? Tan alpha is equal to BC upon AC and BC is equal to V plus del V by del S delta S into delta T minus, so this has gone up to this point and minus, we will see like if I'm saying here, if I'm saying V is equal to 0, U is equal to 0 because it has not moved anything from at this point. So we will make this the later part. So this is your BC divided by what is the value of AC? That is delta x plus u plus del u by del x delta x into delta t. So this is your like this form is your um, delta x plus this value. Now initially we said that our v and u is equal to 0 because it has not moved a single bit. So this is equal to 0 and this is equal to 0. Therefore del v by del x delta x delta t divided by delta x plus del u by del x delta x delta t. So since it has been multiplied with a smaller quantity, it is very less than delta x and hence we can ignore this term and tends to 0 and this delta x will cancel out. Therefore tan alpha is equal to del v by del x into delta t. And since alpha is very small, we can assume that tan alpha tends to alpha and that is equal to del v by del x into delta t or alpha dot. If we take this term here, the rate of change of motion of this axis, it is del v by del x. And similarly for beta, if we do, it will be del u by del y. So the rate of angular deformation, I am writing it as not the same expression, gamma xy rate is equal to alpha plus beta because both has changed and that is equal to del v by del x plus del u by del y. This is rate of angular deformation. Now here also one term also came, it is rotation. Omega or what is the rotation? So omega z is equal to average of alpha dot minus beta dot. So whatever be the change in the alpha and beta, it is the average because it is in clockwise, counterclockwise direction. It is clockwise direction. It is coming in the negative sign. So it is half of del v by del x minus del u by del y. This is the rotation, and why it is written in Z plane? Because this rotation has been made in this Z direction perpendicular to X and Y. X and Y, it is perpendicular to Z direction. Therefore, we have three terms. That is linear deformation. Linear deformation, that is equal to del U by del X plus del V by del Y plus del W by del Z is equal to 0. That is for incompressible, or linear deformation is this. Okay, for each of the components. We have angular deformation, and that is equal to, suppose I am writing it as gamma xy dot, that is equal to del v by del x plus del u by del y. Similarly, for any other plane, suppose gamma xy, it is gamma yz, it is gamma xz, you replace the variable and that will be same. For rotation, we have, I am writing at omega z, it is equal to half of del v by del x minus del u by del y. So for any other plane, so suppose you write in the plane of x and plane of y, it will be like this only. So this omega has been written in a vector notation as omega vector is equal to half of curl of velocity vector. So if you know that this is a in a linear algebra part, this is called the curl of velocity vector. So how it will expand is curl of v is equal to I j k del of del x, del of del y, del of del z, u v w. So if I will write I cap into del w by del y, so if I leave this part, it is del w by del y minus del v by del z minus j cap. I hope you know how to do this vector multiplication. If we leave this part, it is del w by del x minus del u by del z plus k cap del u by uh, del y minus del v by del x. So if you put half around each of the terms, it is this rotation term. So omega x is equal to this first term, omega y is equal to this second term, and omega z is equal to this third term. So this is the rotation of the any fluid element. Now we will try to solve some problem like this in this form. So I will take out problems. Okay. So we have velocity vector that is equal to 3x y square I cap plus 2xy j cap, and we need to find what is linear, what is total sum of, like, whether first we will find rotation, and then we will find the what is the epsilon x plus epsilon y, and we will find the gamma xy. Okay, so if I define rotation is equal to omega z, because it's an xy plane, it is del u by del x minus, sorry, del u by del y minus del v by del x. If I write this in this way, it is, if I derivate this, this is u component and this is v component. So u component with respect to y, it is 6xy minus del v by del x is a 2 y. And if I point it at 1 comma 2 point, so it is 6 into 2 minus 4. So it is 6 to the 12 minus 4, that is 8. That is 8 into some unit of radian per second or whatever we are in, so it is units. Now What is this? This term is called is equal to summation of linear deformation or rate of change of volume that I explained here. If you see at this point, it is rate of change of volume 1 by V del V by del T, rate of change of volume. So if I write this way, it is del U by del X plus del V by del Y. So what is del U by del X? If I differentiate, X will be go from here 3y square plus del V by del Y. So if Y will be go from here, it is 2x. So I will put 1 comma 2. It is 2 to the 4 is a 12 plus 2, that is 14, and this is not equal to 0. Therefore, we can see that the fluid is, because summation of rate of change, it is also called volume. So the volume 1 by V del V by del T is equal to epsilon dot x plus epsilon dot y is equal to 14. So it is not equal to 0. Therefore, flow is not incompressible. Okay. Now, what is gamma xy? Gamma xy is equal to del u by del x plus del v by del y, and sorry, del u by del y plus del v by del x, and it is equal to 12 plus 4, 16, 16 units. I hope you can find now how to find the rotation, what is the shear, like what is the angular deformation, what is rotation. Now we will, like, some explanation is there. So if gamma xy is equal to 0, first we will do this. Epsilon dot x plus epsilon dot y, or that is equal to del u by, I am taking only two dimensional, it can be in three dimension also, plus del v by del y is equal to 0. So if this is happening, then flow is incompressible. So one comment is this. Second thing is, if gamma xy is equal to 0, what it means? It means del u by del x del y plus del v by del x is equal to 0. And what is the meaning of this? That there is no any angular deformation, or whatever be the angle that is preserved later. So suppose this was your initial fluid element, it has changed from this to this, and your alpha that or and beta, the rate of alpha is equal to the rate of change of beta. So whatever has changed from here, this has changed from here. Therefore, it has its difference is equal to 0. Sorry, summation is equal to 0, and therefore we can say that it's a pure rotation. Why pure rotation? Because the change has went in this direction, or del u by del y is equal to minus del v by del s. Now, there is no any angular deformation, no any angular deformation. Now, what happens if your omega z is equal to 0, or del u by del y minus del v by del x is equal to 0? That means del u by del y is equal to del v by del x. And the example of this is, suppose this is your fluid element, this plane has moved here, this plane has moved here. Suppose this is it, and this is a alpha, this is a beta. So alpha dot is equal to beta dot, uh, but so this is in negative way and this is positive. That means these two values are same and has moved with each other, that's the diagonal that was initial is remains the diagonal. The diagonal doesn't change from its direction, and this is called irrotational because there is no any rotation in the fluid element. No rotation in the fluid element. So the fluid is irrotational. We call this as irrotational flow. Now we have different terms, that is incompressible, irrotational, pure rotation. Okay. So you need to understand the basic differences. What is the meaning of each of the terms and what is like incompressible meaning, irrotational meaning, pure rotation meaning, because this will help you to solve the problem in like in your later stage. So I have one like question. So question. So suppose you have given a velocity u is equal to x plus y and v is equal to x minus y, and you need to find whether the flow is incompressible or not. So what you need to do is, so the condition of incompressibility is del u by del x plus del v by del y is equal to 0. So if I derivate this term with respect to x and this term with respect to y and check if their summation is 0, then the flow is incompressible. So del u by del x is equal to 1 and del u by del y is equal to minus 1. So their summation is equal to 0. Therefore, this whatever be the flow that is happening because of this u I cap plus v j cap is incompressible. Now, the second thing is, suppose given v velocity component, so suppose your v vector has u I cap plus v j cap two-dimensional flow, and your v velocity component is y square minus 2x plus 2y, and it is said that flow is incompressible. Therefore, find x velocity component or find u. So how we will do this? So if it is incompressible, then del u by del x plus del v by del y is equal to 0. Now what is del v by del y? It is 2y plus 2. Okay, it is 2y plus 2. Now del u by del x is equal to minus 2y plus 2. So we will integrate this. Del u is equal to minus 2y plus 2 integration dx. So if I integrate, u is equal to minus 2yx plus 2x, okay, plus some constant. So this is your u velocity. And now what is this constant meaning? So you are integrating with respect to x. So this constant can be some constant value or some function of y. Now why some function of y? Why not some function of x? Because if I derivate it with respect to x again is equal to, so this term will be remains the same 2y plus 2 and it is plus dc by dx, del c by del x. Now if this c is a function of x, then this term exists a value and here it is 0. Therefore, this can be possibly a function of either a constant value or a function of y. Then only this term can be eliminated to 0. Okay. Therefore, this is the u component. Suppose I'm taking c as equal to 0, u is equal to minus 2yx plus 2x. So for incompressible, Since v is given, we can find the u. Uh, Hello, is it okay to you?
Yes, sir.
Hello. Okay. Now, we will try to find, like, suppose for this velocity component only, uh, v it is given, v is equal to y square minus 2x minus 2y, minus 2y, and I am saying that flow is irrotational. Flow is irrotational, and find u velocity. So for the flow to be irrotational, omega z is equal to 0, or del u by del y minus del v by del s is equal to 0. Therefore, if I am writing it del u by del y minus del v by del s, if you derive with respect to s, it is minus 2. So it is plus 2 is equal to 0. Or del u by del y is equal to minus 2, or we can write it as u is equal to minus 2y plus some constant value of x. Because as earlier I said, if you integrate with respect to y, it can be any constant that can be a function of x, or it can be a function of like a constant value. So I'm taking this as a 0, u is equal to minus 2y. So for the flow to be irrotational, this term holds good. Like u is equal to minus 2y. Therefore, velocity component is equal to minus 2y I cap plus y square minus 2s minus 2y j cap. And we can prove this from omega, that is del u by del y minus del v by del x. And we can differentiate. So if you differentiate it, what will happen? This term will go to minus 2, and this term will go to plus 2, and this is equal to 0. Therefore, omega z is equal to 0. Okay, this is the this is how the irrotational, how the incompressible things are solved. So if you have any, do you have any question till this point? Hello?
No, sir.
Okay. Now we will introduce one concept, then we will end this lecture. So earlier I told that Lagrangian approach or system approach and Eulerian approach. So every law of physics has been defined for a system, for system. Like what I told is the force is equal to mass into acceleration. Thermodynamic law that del Q is equal to del U plus del W. So whatever been applied to a system, these laws are made for the system. In Eulerian approach, what we need to see is how we can apply to a control volume. So from shifting from a system to a control volume, we need a theorem that will shift this system laws to the control volume of laws. So that theorem is called Reynolds transport theorem. So I will explain what it meaning. So suppose if you say you have uh, you have a let's say account, and you are putting some money in, you are taking out some money, and some interest has been given. So we need to find out what is the total money in the account. So suppose at money at any time is equal to whatever be the money in minus money out plus interest given in the account, interest given. So in the similar way, suppose we have a control volume and some mass is coming from inside, some mass is going outside, and something is accumulating inside. Therefore, that is equal to whatever be the parameter, the rate of change of that parameter in system approach is equal to, or I should write it in this way. So rate of change of this parameter in control volume is equal to whatever be coming in minus going out plus generation term. Therefore, the final expression of an order transport theorem is, so suppose you have a control volume and some parameter n is coming inside from state point 1 and some is going out from here. So the rate of change of this parameter with respect to system is equal to the rate of change of this parameter with respect to control volume plus whatever be the property efflux going out of the system. So this is what is the meaning of a Reynolds transport theorem. So suppose I am saying that n is some property and small n is equal to capital N by divided by the mass. Therefore, the rate of change of this property with respect to system is equal to d small n d capital and dt by control volume plus whatever be the property it is going out of the system. So I am writing it as cyclic integral of, sorry, not surface integral of rho, it is v dot n cap into dA, and this is the mass plus that is going out for the system because this is the volume flow rate into area. This is volume flow rate multiplied by the rho is the mass into small n because it's the intensive property. Or we can also write this capital N as, this is for the control volume, so we can write it as del of del T of integration over the control volume rho dV plus integration over a control surface n rho v dot n cap into dA. This is rate of change of any parameter for a system. So we will take this thing and we will do the mass conservation and then we will solve some problem. So suppose is capital N is equal to mass. So what is the small n? It's the mass divided by mass that is equal to 1. Um, Rho dV into n. Okay, it's like this. Now dm by dt for a system is equal to d dt of control volume rho dV plus control surface because n is equal to 1, small n is equal to 1. Control surface rho v dot n cap dA. Now, as you know from the law of mass conservation, that uh, mass cannot be created or destroyed. Okay, so this term, the rate of change. So suppose for any system, the mass is present inside and it cannot go outside and cannot come outside. Therefore, rate of change of that mass of the system is zero. This term is equal to zero and this is equal to del d of dt of control volume rho dV plus control surface rho v dot n cap dA. So what is the meaning of this? So suppose you have a control volume and you have some like density, and this is your dV is total volume. So this is the total mass that is present and the rate of change of the mass within the control volume plus this is the mass. So if I'm suppose writing in this way, it is out, it is in. So this is equal to, if I'm saying that V is Vi cap and n vector is non, this is the area that is coming out. So the normal to this area is the n cap. So it into n cap is also I cap into dA is some, suppose dA is equal to some dx vector, ds value. So it is I dot I is equal to 1, I dot I, so V into dx. And if you multiply with rho, it is rho V dx, and that is equal to your volume, or dx is a in one direction. I should write it in, let it be in dA only. So it is dA. So rho V dA is a mass that is coming from this point. Similarly, for this point, if we write, so suppose this is the point, here the element is dx and sorry dA, and the area towards its n cap, and that is equal to minus I cap, because in the negative x direction. This is your positive x direction, this is the negative x direction. So it is rho into V is Vi cap, because velocity is going in this direction, it is Vi cap into minus I cap dA, and that is equal to rho V I into minus I is minus 1 into dA. So this is the like you can integrate this thing over this area, and this is the rate of change of your velocity. Now we will try to like solve some questions so that it will be like, it will be helpful to you. So suppose you have a tank, you have a tank which is like suppose this is closed tank, and you have some port that is some gas is present, and some port where it is leaving. Okay. Now we need to apply the, we need to find what is the rate of change of density d rho by dt within the system. And it is coming out with some velocity v, and area of cross section is A. Therefore, if we write the mass conservation equation, 0 is equal to del T of rho dv control volume plus control surface rho v dot n cap into dA. So this is the gas. Now, if I am saying that um, I'm I'm trying to like expand this thing. So since it is a rigid container, the rate of change of volume we can directly integrate it, because it is not the parameter with respect to time. So if I write it in this way, del T of rho into volume, because the total volume is not a function of like this is a control volume, and we can because it's not dependent on time, we can directly integrate this. And this is equal to what is whatever be the mass coming out, and this is equal to velocity rho va. So 0 is equal to del of del t of rho plus uh, v. I am doing it in a partial like partial derivative, plus rho of del v by del t plus rho va. So as this is a rigid tank, this term is equal to 0, because the volume is not changing with respect to time. Tank volume into change in density is equal to rho v into A minus, or del rho by del T is equal to minus rho VA divided by the total volume. This is the change in density within the tank. So if you know whatever be the mass, so this is the total mass. So if you know the mass that is coming out divided by the total volume, you can obtain whatever be the change in density of the system. Okay. Now we will try to do one mass continuity equation. So also the continuity equation this explained here is in the integral form. This is called the integral form of continuity equation. Now we will try to analyze the differential form of continuity equation. So first I will write just rho dv plus control surface rho v dot n cap dA is equal to 0. Now we will do what we'll do. We'll take this derivative inside this system. So this integration has been made on a control volume, and if your control volume is not changing with respect to time, then you can take this integration in and out of the system without doing any work. So control volume del of del T of rho dV plus control surface of rho v dot n cap dA is equal to 0, and or this is equal to del T of rho dV plus we will apply Gauss divergence theorem at this point. Gauss divergence theorem, and that will change the surface integral to a volume integral. So it is divergence of rho v into dv is equal to 0. Now this is also volume integral. This is also volume integral, and this is also volume integral. So we can take out that thing. So control volume del T of rho plus divergence of rho v into dv is equal to 0, and therefore this since this cannot be 0, therefore this only part can be 0, that is del rho by del t plus this one into rho v is equal to 0. Now if we expand this form, this is called a conservative form of conservative differential equation. So earlier this was integral form of continuity equation. This is called the differential form of continuity equation. It is in conservative form. Now we will do one thing, del rho by del t plus, if we expand this form, what will happen? Divergence is del x of I cap plus del y of j cap plus del z of k cap dot rho u I cap plus rho v j cap plus rho w k cap is equal to 0. So if I do this, what will happen? It will be del x of rho u, because I will go with I, j will go with j, and k will go with k. It's a dot product. Plus del y of rho v plus del z of rho w is equal to 0. Now we can do one thing. We can split this rho and u separately from each of the equation. Rho del u by del x plus u into del rho by del x plus v into del rho by del y plus rho into del v by del y plus rho into del w by del z plus w into del rho by del z is equal to 0. Now we have two terms, del rho by del t plus u del rho by del x plus v del rho by del y plus w del rho by del z. This is one form, and this is another form. Rho del u by del x plus del v by del y plus del w by del z is equal to 0. And if you remember your acceleration term, we write? Del v by del t plus u del v by del x plus v del v by del y plus w del v by del z, and this is acceleration is equal to total derivative with respect to time, or it is called the material derivative. Now if we replace V with the rho, what it will be? Del rho by del T is equal to del rho by del T plus U del rho by del X plus V del rho by del Y plus W del rho by del Z. So this form will be d rho by dt, complete material derivative, plus rho del u by del x plus del v by del y plus del w by del z is equal to 0. So earlier from the equation we know that for incompressible flow, this term is equal to 0. This term is equal to 0. What it means is d rho by dt is equal to 0. So for incompressible, d rho by dt is equal to 0. That is the so sometimes people used to misunderstand that for incompressible this is the statement, and for from this statement this term will come that del u by del x plus del v by del y is equal to 0. No, this is the term that is coming from incompressible, and this will lead to this term. So this is the cause and this is the effect. Okay, so we don't need to misunderstood that from where this is coming from the kinematics, and this kinematics will go from here to here. So this kinematics will help us to make the system like for incompressible, it is like this. So this is for the Cartesian coordinate system. But if we look for the cylindrical coordinate system, I will just give you as a how it will be. So it is some r theta coordinate system. I am taking not taking the z coordinate system. So uh, we will not derive with the RTT. I will give you, or I think it's better to first give you one glimpse of. So suppose this is your one control volume. Some mass is coming mx. This is your x direction. This is your y direction, and some mass is leaving from here mx plus this is delta x del x of m dot x into delta x. Some mass is coming from here. It is my m dot y, and it is m dot y plus del y m dot y into delta y. So the rate of change of mass del m by del t inside the control volume is equal to whatever be the coming mass in, that is mx m dot x plus m dot y, minus whatever be the leaving mass, that is m dot x plus del x of m dot x delta x minus m dot y into plus del y of m dot y delta y. So this term will go away, this term will go away, and you will get del m by del t of control volume plus del x of m dot x. So yes, m dot x into delta x plus del y of m dot y into delta y is equal to 0. And you can split mass is equal to rho a v. So that will go inside again. So here also del t of rho a. Oh, sorry, I should write in this way. Del t of rho dv. This is for the elemental volume, or it is rho a into delta x delta y plus del x of whatever be the mass that is coming in. So this is delta y. So it is u into delta y. So I'm taking unit depth inside. So this is your volume into d into rho. This is your mass into delta x plus del y of. So from here v component is there and it is entering with delta x element. So it is V into delta x into rho into dx is equal to 0. Um, so if you take delta x delta y and take it from the RHS, uh, this is not there. So it is del rho by del t plus del x of rho u plus del y of rho v is equal to 0. So this is from a control volume approach. Take a small element, we can get directly from this. And earlier we had get this equation from a Reynolds transport theorem. So in these two ways, you will get the same equations. Also, for the cylindrical coordinate system, what you can do is take this cylindrical element and suppose this is your r direction and this is your theta direction. So if I'm saying this as theta direction, d theta changes. This is theta. So here some mass is entering mr, and this is delta r, and this is delta theta. So some mass is leaving, that is mr plus del r of m dot r, the delta r. And from here some mass that is entering is m dot theta, and some mass that is leaving is m dot theta plus del theta of m dot theta into d theta, delta theta. Now you can simply, what you can do is that what I earlier did is whatever be the control volume, so what is the area? So this is your R and this is delta R. So what is the area that is we are searching? So dm control volume dt is equal to whatever be the mass that is coming in minus rate of mass that is coming in minus rate of mass that is going out. And this is equal to, if I'm saying this is R, this is delta theta, this is R delta theta into delta R. So I can split the area as R delta theta into delta R. This is your at some radius R. This is R delta theta, this length into delta R. So I'm taking as a rectangular element. Assumption is there into rho. This is the total mass is equal to. If I am writing, it will be minus of. You can solve this by your own. Minus delta R of m dot R delta R minus del theta of m dot theta delta theta. Or what is m dot R? M dot R is rho into the area is R into delta theta. This is your so this is your area, and taking a unit depth, that will be volume. Now what is m dot theta? M dot theta is delta R rho, that is your into unit depth. So this is your like uh, m dot. This is your length into, I think one thing is missing. Uh, yes, yeah, okay. So m dot r into delta r. So this will be like this. Now if you put this value here, del t of rho r delta theta delta r is equal to minus del r of rho r delta theta delta r minus del theta. Oh, sorry. So UR is missing. That's what I'm saying. UR is missing. Here U theta is missing. So here UR plus minus this into rho delta R U theta del theta. So we can take del theta outside, but since R is a function of del R, we cannot take outside. I'm writing it in this way. UR into R into rho delta R delta theta minus del theta of rho u theta del r del theta. And what you will do is you will take this del r del theta and cancel from both sides and take this r in this right hand side. You will get del rho by del t plus 1 by r del r of r u r rho plus 1 by r del theta of rho u theta is equal to 0. This is a continuity equation in cylindrical coordinate system for a two dimension. You can like expand this thing in the third direction also. I hope you are getting this, Shiven.
Yes, sir.
Yeah. So you have any doubt because we are ending this lecture? Hello.
So can you explain this slide once more?
Oh, this cylindrical coordinate system.
Yes, sir.
Okay. So I will try to explain this in a like I will make a big picture. Okay. So suppose this is r theta coordinate system, and this is some cylindrical portion of the cylindrical element. This is some delta theta with theta, and this is with some radius r. Okay, and the increment in the radius is delta r. So this is delta theta, this is delta r. Now what will happen is this element is arc is equal to length radius into the whatever be the angle suspended between them. So this length is r del theta, and this is delta r. Now some mass is coming from this direction. So this is the radial direction. We are seeing m dot r, and this is m dot r plus del r of m dot or delta r, because this has length has increased from delta r. Now from this direction, some m dot theta is entering, and from some this direction, m dot theta plus del theta of m dot theta d theta is going outside. Now what is m dot r? M dot r is whatever be the area. So it is rho. Suppose what is mass? It is rho av. Now rho is there. What is the area? It is r del theta, and I am taking unit depth perpendicular in the z direction. Okay, in that z direction I am taking unit depth, so it is that is will be 1. So this is area, and whatever is the velocity in r direction, it is u r. Now what is m dot theta? It is rho. The area is delta r into u theta, because perpendicular I am taking unit direction. So if you take derivative like whatever will going in inside, so m dot r will cancel from both sides, m dot theta will cancel from both sides. Only term that will remain is this and this. So del r of m dot r delta r is equal to del r of rho r del theta u r into del r. So I had substituted this here. So here rho can be function of r can be function of r, but del theta is not a function of r. So I'm taking it outside, rho r u r del r del theta. So that what I had put it here. And similarly, del of del theta is equal to uh, del of del theta rho, sorry, uh, del of del theta of rho u theta into delta r delta theta, because that is coming from here. Now you can simply divide the both, like if you put compare the theta term r term with respect to this term, you will get this expression. So you just to do the practice and you will get to know that it's very easy, but uh, while deriving it's like seems to be complicated, but it is not that. I hope this clears to you.
Yes, sir. Now it is
Okay.
clear.
Yeah, okay. So okay, then we'll end this class.